In this lecture, we're going to set up where we can click and drag on the UI, show a box where we're going to be selecting units within, so in a future lecture, we can select those units. Before we jump into just implementing something, let's take a look at our game view and imagine what do we want to do. There are some complexities here to consider that can really get us if we're not careful. Right now we have, if we left click, whenever we release the mouse button, a unit gets selected. Conceptually, a drag select means we're going to, as soon as we press the mouse button, take a snapshot of where that was, and then find all units that fall within whatever box we drag whenever we let go. But now think that we have two things that may need to happen when we let go of the mouse button. We may want to select all the units in that box between wherever we started and ended our drag. Also, usually when we drag select, we want to deselect any units that were not in that selection. So if we just drag select right here over this left unit and we had this right unit selected, this unit on the right should become deselected and the left one should be selected. So while this seems like a pretty simple, straightforward thing, there's actually quite a few things we need to keep track of. And very importantly, we need to also show something to the user when they're drag selecting, because right now I have no idea where I've started dragging. So let's start with showing to the user the thing that they're dragging. If we click on our scene view and click the little 2D icon up here at the top right, that transforms us into 2D space. And this scene came with some UI for us already styled, but it doesn't really do anything right now. That's under this runtime UI UGUI. You can theoretically do this here as well, but you have to start fighting with the order of things, and I find it's just pretty complicated to do this all in a single canvas. So I like to make a selection canvas by just right-clicking the hierarchy, UI, canvas. We can name it selection canvas. And over here on the right side where we have our canvas scaler, this is super important that we have this set to UI scale mode, constant pixel size. If you pick any other value or change the scale factor or reference pixels per unit, the math we're going to use later is not going to line up quite right, which is another great reason to put this on its own canvas. We can force this canvas scaler configuration regardless of whatever our main UI is using. For example, on this one, we've got the canvas scaler at scale with screen size, expand, targeting 1920 by 1080. Now, if we bring our selection canvas in the hierarchy right next to our other UI, keep those two together, there's only one thing we need to do on this canvas. We right click UI image. Let's name that selection box. And let's give it some color that's partially transparent. I'm going to use this 68 BDFC at about 0.5 alpha. The color is not really important. Pick whatever you like the best. Again, very importantly for our math, we're going to want to set our anchors here to the bottom left. Remember that our mouse position is oriented from the bottom left. So you might now be getting where we're going to go with this. We're going to take wherever we click, put this thing at that location, and then we're going to scale it based on the mouse movement. So if we come to the game view, maybe 0.5 is a little bit too much alpha. I'm going to go 0.2. And let's set this to be a smaller size, like 0 by 0. And disable it. Let's hop over to VS Code. We're going to start in our favorite class, the player input. Now you heard me say that we do need to keep track of some stuff. Let's start at the very top by defining a private vector2 starting mouse position. That's the key, most important thing we have to track, because wherever we start, that's where we're going to resize this box based on our mouse current position. If we come down to our update, we've got panning, zooming, rotation, left and right click. Let's also do handle drag select. And we're going to define that as what? Private void handle drag select. And conceptually, there's three states that we care about here. And we're going to define those in if statements in order that they should happen. So first, if the mouse left button was pressed this frame, we're going to do stuff like enable the UI and store that start position. Then we can do else if mouse current left button is pressed, so it's currently pressed, and it was not pressed this frame. And here we're going to resize that selection box. So this is like that dragging state. And the last case is if we've released the mouse button. And whenever we release, what do we want to do? We want to select the new units. We want to deselect whatever units were not in that box. And we want to disable that UI element. So we don't have a reference to this UI thing. Let's go ahead and get that. Back up at the top, we can do a serialized field, private rect transform selection box. We don't actually care what type of thing this is. We happen to know that it's an image, but we want the rect transform because that's what we're going to be directly manipulating. It has the key things like the position, size, anchor, all of that information of our rectangle, which is only available on the canvas. Coming back down to our handle drag select, based on our little algorithm here, whenever we press the left mouse button, we want to enable the selection box. We can do that with selectionbox.gameObject.setActive to be true. And as I'm typing this, remember that it's possible for us to not assign this in the inspector, which could lead to errors. So at the very top of handle drag select, we can just use our guardian pattern. If the selection box is null, we'll just return and not do this. Now in that first if again, if we've pressed the mouse button this frame, we can also set the starting mouse position to be the mouse current position.readValue. So great, now we can see something. We've put the starting position here. While we're dragging, which is going to happen every frame because we're calling this on update, we're going to want to resize the selection box. In here, we can get our mouse current position exactly as we did before. Vector2 mouse position equals mouse.current.position.readValue. That way we don't have to type mouse.current.position.readValue multiple times. And we can calculate the width and the height by doing the current mouse position, subtracting out the starting mouse position. So we can do float width equals mouse position.x minus starting mouse position.x, and just duplicate that for the height, checking the mouse position.y minus starting mouse position.y. We can then do selection box.anchored position equals the starting mouse position plus a new vector2 with the width and the height divided by 2. Now in UGUI, whenever we're dealing with rect transforms, instead of just setting a position, we set the anchored position. You can think of this as doing the same thing as just setting transform.position. And finally, we need to set the size delta to be a new vector2 with the mathf.absolute value of the width and the height. So we don't want it to be a negative size because we are moving the anchored position based on the width and the height. Now, I know this is a little bit abstract and it's not a lot of fun to just copy along as I'm writing code. So let's take a look at why we have to do this over in the Unity editor, where we can get a visualization that makes it a lot easier to understand. On our main camera, we need to first hook up our selection box to our player input selection box. So we drag that, click play. If we left click, start moving the mouse, we can see this box is appearing exactly where we expect it to. If we select the selection box in the hierarchy, so we can see it in the inspector, as soon as we click, we can see that the X and the Y position are set. So I've got it right around 502, 850. As we start going right, we'll see that X position is changing by about half of the width, which is exactly what we would expect because we set the X position to be the starting position minus our current position. So over here, it's 504. Over here, it's almost 1,000. 504 minus 1,000 gives us that width of about 500. And then our X position is changed by half of that. And the exact same process happens on the Y. Except down here, our Y position is about 586. And up here, it was 900. So we're going down. That gives us our 400-ish height. And our Y position is now 200 less. Now, the reason for all of this being half, if we pause the player with Control-Shift-P, come over to the scene view, we have in UGUI this concept of the pivot. That's this blue circle. Because this pivot is by default in the center of the object, as we increase the width or the height, we have to also adjust our initial anchor point by half of that amount because it's halfway in the middle, right? So that's why we had to do it that way. If you really hate that, an option for you is to take the X, set to be 0, so it's all the way over here, and Y to be 1, so it's all the way up here at the top left. And then you'll notice if we resize this, you don't have to do any of that dividing by 2 business because the X position stays where it is and it just comes out and just comes down or up. Either way, not a big deal. I find monkeying with the pivots sometimes is more annoying than it's worth because then you have different objects that all behave differently. So leaving it at the center works fine for me at the cost of just having to do new vector2 with the half of the width and the height. The last thing we want to do now is make sure that whenever we let go of the left mouse button, we disable this on the UI because we don't really know anything about our units yet. That's going to come later. So we can just do selectionbox.gameObject.setActive to be false in that last else if. And before we go, my challenge to you, that's right, you're not getting out of this lecture without a challenge. My challenge to you is to refactor our selection box resizing code into its own private utility method called resize selection box. So pause the video, refactor that little piece of code right there to its own private utility method, and I'll see you back here once you're done. All right, welcome back. I hope you're able to do that. We've done stuff like this multiple times already. We can just cut all of this out. We can just call resize selection box in that else if. Define that private void, resize selection box. Paste all that code in there. And that's it. That's a really quick, simple refactor that makes seeing what we're doing here much easier. We're going to be doing that a lot, so make sure you know how you can do that quickly and effectively. I think that's all we have time for in this lecture. So if you're eager to get started on actually selecting these units, I'll see you up on the next lecture.